Hello, K-Squid listeners. It's every other Sunday again, and you're listening to Sustainability Now, a bi-weekly K-Squid radio show focused on environment, sustainability, and social justice in the Monterey Bay region, California, and the world. And we are your hosts, Brooke Wright and Ronnie Lipschutz. In the spring, elephant seals turned to love and fighting and feeding and laying around in the sun. We're just past the prime viewing season at Año Nuevo State Park, during which 2-ton male seals fight bloody battles. The females give birth to young conceived the prior year, the adults mate, and the wiener pups look cute, or so I am told. According to the San Francisco Chronicle, UC Santa Cruz scientists go into high gear from mid-January to early February each year, when scores of female seals return to Año Nuevo to give birth following foraging journeys of about 6,000 miles round trip to the middle of the Pacific Ocean. Since the 1960s, hundreds of deep-diving seals have collected data for scientists at UC Santa Cruz, which manages a natural reserve within the park, and universities around the world who research not only seals, but the ocean itself. This show is a rebroadcast of a 2022 conversation with Dr. Teresa Keats about her dissertation research on elephant seals. Keats received her PhD in ocean sciences from UCSC in 2022. She is currently a legislative analyst with the California Energy Commission. Her research is centered around deploying oceanographic tags on elephant seals, which offers both a source of valuable oceanographic data from remote regions, as well as a unique platform to investigate these very large marine mammals. So, put on your sea duds and let's go. Teresa Keats, welcome to Sustainability Now.
Hi, thanks so much for having me.
It's great to hear from you. Before we plunge into the ins and outs of elephant seals, let's get some background on you. How did you get into this business and your current line of research? I mean, people don't every day say, I'm going to go study elephant seals.
Well, going really far back, I'd say, back in elementary school.
Wow.
I loved animals, as I think most kids do, but my parents got me this book for Christmas that I think was called like 1,000 Facts About the Earth or something like that. And I was really fascinated just learning about geology and animals and all of this. And the very end of the book had something about how humans are affecting the planet. And this was my first exposure to the fact that we are actually damaging this planet that we rely on. And ever since seeing these drawings of smokestacks and of deforestation, it's kind of been my goal to enable us to better understand our planet so we can be better stewards of where we live. And since then, I've done a lot of different things. I did my undergraduate degree in biology. During this time, I was studying harbor seals. I would swab the outside of harbor seal scat to figure out what they ate, and genetically, really glamorous, I can tell you, to understand the interaction between them and salmon fisheries. This was up in the Pacific Northwest. I've also worked in the San Francisco Bay marshes doing wetland restoration, and now find myself in Santa Cruz in graduate school studying elephant seals.
You know, I can't help but think that when I was, well, even when I was your age, it was only after, Earth Day had only started a few years before. We didn't get books like that. So you're in the Costa Lab at UCSC. What does the lab do more generally?
So this is the lab led by Dr. Dan Costa at UC Santa Cruz. And it focuses on a number of different marine predators, primarily seals, the elephant seals, but we also have students past and present that have studied other seals and sea lions up and down the West Coast or in the Galapagos, even in Antarctica. And we've done some work with whales and with seabirds as well. But I think the main project that we have going and have had going for decades is the work with the elephant seals at Año Nuevo State Park. And this has been going since Dan Costa's predecessor, Bernie LeBoeuf, who started this program in the 1960s. And I'll say that everything I'm about to talk about is not just my work. It is decades of knowledge in the making and a lot of work from many, many different researchers and both undergraduates, graduate students professors, volunteers. It is really a massive group effort. And of course, our most important collaborators are the seals themselves.
I guess it takes a village. Do you have any idea why Barney started this research? Was it some interest that he had, or was it just because he knew there were elephant seals up at Año Nuevo? I'm just curious about, what instigates this kind of long history of research on particular species.
I can't speak completely for him, but when he did start, this was after the elephant seals kind of started making a comeback. And I think it was a really unique opportunity to study how a population of seals that was so close to extinction once was making a comeback. So when he started in the 1960s, actually no seals were breeding at Año Nuevo on the mainland, just on the island. Oh, okay. So if you go out to the park, you'll see there's an island out there that has a big house out there. They were breeding out there, but not the mainland. And it wasn't until, I think, the 1970s, 1975, that the first pup was born on the mainland in Año Nuevo. And they just took off. The population has grown since then. So being able to study this recovery of a population has been a really unique insight into how these things can occur.
So we had Jim Estes on the show last year to talk about sea otters and the dining habits of orcas off the Alaska coast. And our very own Emily Dunham, who was our engineer, talked about kelp and sea urchins. There's a lot of marine research going on at UCSC. Do you have any idea how broad it is? You mentioned a little bit about it, but it's sort of interesting to me how much there is.
The Monterey Bay area is such a hotspot for marine research. We're really lucky to be here, whether it's studying the deep sea, because we have this massive canyon in the middle of the Monterey Bay, to our local elephant seals that people from all over the world come to see.
Brooke, do you want to ask something?
Oh, just hello and thank you for being here.
Hello.
So of all those things, what motivated you to choose elephant seals in the end?
So I think more than the elephant seals specifically, I was really interested in how we could learn about how the physical ocean affects biology. And we know the ocean is changing. It's changing really quickly. It's warming up, it's acidifying, and the effect that this is going to have on ecosystems is often really hard to say. And one beautiful thing about working with elephant seals is they can kind of tell us how their changing environment is affecting them. So because we have data going back decades, we are able to notice when things change because we have kind of this baseline information. And by studying their relationship to their physical environment, we can better predict how a changing ocean will affect different ecosystems so that we can then better plan for and mitigate the effects that it will have on us, whether it's, fishery stocks that are shifting due to changing temperatures or priority regions for protection in the open ocean, like marine protected areas. So really, it's the elephant seals that are teaching us about their environment. At least that is the focus of my research.
That was actually the next question.
Oh, great.
Tell us more about the focus
more
of
detail.
Your research.
Okay.
Yeah, let's hear about that.
So, similar to, say, a Fitbit or a Garmin watch that a lot of us own, we use miniaturized technology to track these seals. This is why we know that they travel these great distances. And they're also measuring pressure so we can tell how deep they're diving. And the specific tracking devices I use, and a lot of other researchers do in different oceans, also collect data on ocean temperature and on salinity. And some that I use also measure chlorophyll fluorescence. So this is, it tells us how green the water is essentially due to algae. So it's phytoplankton, it's the base of the food web, and we can actually measure this using light on a little device on a seal. So as these seals are diving, they're collecting this really valuable oceanographic data. And in addition, of course, they're not randomly swimming through the ocean. They are looking for food. So by combining these insights, so using that oceanographic data along with the seal behavior, we can learn something that our technology itself could never tell us, which is where is the food in relation to these oceanographic conditions and how might that be changing? And because they dive so deep, which we'll probably get into some of the amazing feats that elephant seals can do, it's extremely hard to study these ecosystems in other ways. And so it's kind of a dual purpose of understanding elephant seals, and then we get this amazing insight into their environment as well.
Do the elephant seals object to this, having these things installed on them?
So all of our studies suggest no.
Do they notice it at all?
We don't know. So, you raise a really important point, because I think anytime you interact with wildlife, you really need to make sure that you minimize your impact, and it needs to be worthwhile what you're doing. The data that we collect needs to go back into protecting the seals and protecting their environment. That's why we collect these data. And we are very lucky with elephant seals being as big as they are. Normal guidelines for putting tracking devices like this on animals is usually don't go above 5% of the animal's body mass. Mm-hmm. These seals are massive. Yeah. So we're at about 0.1% of the body mass of a seal. So that is a very, very small addition. And they're also swimming. So that buoyancy effect comes in. As I learned when I was a small child, I could lift my sister up in the swimming pool. I was so strong. So, the mass is less important when you're. And so it's a very minimal effect, and one that we're continuously studying to make sure that survival is fine, foraging success is unaffected, because that's incredibly important to consider.
Yeah. How do you do it? Where do you attach it?
So these tags are attached to the head, mostly because they have to communicate with satellites. So when the seal comes to the surface, usually just his head pops up. And the tags get glued to the fur. And this is right before the seals leave to go out to sea again. And when they come back, we remove the tag. And if for some reason they go to a different colony, which they do sometimes, and we will do our best to get there, whether it's the Farallon Islands, whether it's the Channel Islands. If that's not possible, because it's just glued to the fur, they shed their fur in a big molt every year, and the tag will just fall off. So it is always a very limited time that this instrument is attached.
And I guess they don't itch, right? So they don't get scraped off. You're listening to Sustainability Now, and our guest today is Teresa Keats, a UCSC PhD student in ocean sciences who studies elephant seals. And we were just talking about tagging them as they go off on their extended journeys and the kinds of data that are returned from these electronic tags. Teresa, I did have one question about the tags. You said that the seal is communicating with satellites, so that the tags also store data for later downloading?
They do.
Oh, okay.
So the seals don't spend a whole lot of time at the surface. Yeah. They usually are only up there about 2 to 3 minutes, and then they're diving again. Uh-huh. So the data that get transmitted that we can just log onto our computer and get are usually a summary of what the tag has on board. And when the tag comes back, when the seal comes back to shore and we recover that tag, we are able to download the full record. So it's a combination of both.
So there are all kinds of seals out there, all right? Where do elephant seals fit into the family of seals, and how do they differ from the ones we see, for instance, under the Santa Cruz Wharf?
So when someone says seal, I think that they're probably referring to either what we call a true or earless seal, or a sea lion, or a fur seal. So we have both sea lions and true seals here. We have a lot of species here. We're very blessed. And the main way to tell the difference between those two is whether or not they have these external ear flaps. Mm-hmm. They all have ears, but sea lions will have this little bit of flesh poking out from their heads. So that's what we're seeing under the Santa Cruz Wharf, for example. Those sea lions also have really large and strong front flippers, so they're able to kind of move on all fours. Those elephant seals do not have the ear flaps, and they also just kind of have to do this, we call it galumphing, kind of like this S-wave to move forward or scoot. Harbor seals, for example, are also these true seals, earless seals. And we get these in the Monterey Bay area a lot as well. And they also kind of just do like the scooching on their front flippers.
Okay. So where do elephant seals fit into marine ecology and food webs?
So they are pretty high on the food web as predators. They primarily eat fish and some squid. For adult female seals, at least, this is out in the open ocean in the North Pacific and very deep. So really, for such a big animal, they're going after pretty little prey. Most of what they eat are lanternfish. They're myctophids, which are probably about the size of your index finger, a little bit longer. So you just have to eat a lot of them. And they are also prey themselves. And we think that their major predators are white sharks and killer whales. Mm-hmm. But it is very hard to confirm this, as interactions have been seen sometimes, but usually it's out at sea. And we do see seals come back with some pretty nasty bite wounds sometimes. Mm-hmm. So,
do you lose? I mean, do you lose a lot of the tagged seals as a result of being predated on?
Not many. No. Thank goodness. The mortality rate for males is usually higher, which we think is due to the fact that males, instead of going out into the middle of the North Pacific Ocean, tend to stay closer to the coast. So they go up towards Alaska and feed along the Aleutian Islands. And this is a place where you can find a lot more big prey. So the potential benefits are huge. When you're a big male elephant seal, you need a lot of food. You need to get as big as possible, as quickly as you can. Otherwise, you have no chance of reproducing. Yeah. And the coast is the place to do it. Mm-hmm. Downside is the coast is where most of the predators hang out as well. So we kind of see this split strategy in which most males stay close to the coast. So there's lots of good food, but it's also really dangerous. And most adult females head out into the middle of the North Pacific, where they have to eat just a ton of these tiny fish and some squid, but there are fewer predators.
And is that the males are so huge? Is that kind of protects them from those predators? Like, how big are they compared to the predators that they're faced with by staying near the coast?
That's a really good question. So an adult male is probably about 4 to 5 meters, which is about 13 to 16 feet long. They're also extremely heavy. So think anywhere between like a Honda CRV or a Ford F-150. They are big. Wow. And white shark can probably be, I'm not a shark expert, but I think that they can be almost that long. Of course, we got a lot of juveniles as well. And I think with the killer whales, their ability to hunt in groups kind of makes any animal almost fair game. They go after animals much, much bigger than themselves. So just because they're big doesn't mean they're invincible. Mm-hmm. Yeah.
I remember that Jim mentioned, and I can't remember exactly the story, but that orcas, killer whales, were going after, I can't remember, were they going after otters or were they going after larger prey because of the disappearance of the otters off of the Alaska coast. Is this predation by killer whales something new, or recent because of the changes in species availability, or is that just something that's, as far as you know, has been happening since time immemorial, as they say?
On elephant seals?
Yeah.
You bring up an interesting point, because the elephant seals were what was almost extinct at the turn of the century.
From human predation.
Yes.
Right? Yeah.
Yes. But then the killer whales wouldn't have had them to
Right.
feed on. So probably not time immemorial, but probably the last many decades. I don't think very much has changed in terms of the elephant seal distribution or abundance.
Well, why don't we turn now to the actual characteristics of the elephant seals? I mean, the males are noted for their large noses. Is that only a male characteristic? And what are those noses for? I don't know what to call them. Trunks, whatever.
We usually call it a proboscis.
Oh, right. Okay.
But nose is perfect. Yeah, that is very characteristic of adult male elephant seals, and it kind of grows as they mature. Females don't have them as much. They have like a little bit of an elongation, but not nearly that large. And in terms of what their function is, we don't fully know. They seem to kind of get in the way a lot, but I think the best hypothesis right now is that it aids possibly in sound production. So adult males make a lot of noise during the breeding season to express dominance and control their harem of females.
Yeah.
But we don't really know.
It's not a secondary sexual characteristic then, or
well,
how's it regarded?
Maybe, but the way we understand the breeding system of elephant seals is females' goal is to just have a pup every year, make sure your pup survives. Then, in terms of evolution, you've been successful. And what they do is just choose the best beaches for that to happen. Mm-hmm. And whoever controls that beach, whichever male is dominant at that beach, will mate with the females there. So we think that the females aren't really choosing the male partners. They're more choosing, where do I want to give birth? But it, maybe it does work as a intimidation factor between each other. But it's a really good question, and one that we don't really know the answer to. For being such a well-studied species, there's still a lot of open questions.
There was something I read that indicated that the male elephant seals, they spend more time on land. They fast for a long period, and that somehow the nose helps them last, like actually keep their level of moisture in their bodies. That it somehow, helped keep them from getting dehydrated because they weren't going to feed, or, which would be the way that they would get more hydration as well.
Yeah, I don't have a good answer for you.
One theory.
Yeah.
I forgot what I was going to ask, but let me ask. So one male dominates a beach, and how do they figure out, or how do they decide, or how is dominance established?
So this is part of what they're so well known for, I think. And if you visit especially in February, you'll see a lot of this going on. Well, let's say January or February. So they establish this social hierarchy amongst each other by fighting initially. So these really old adult males will have this very pink-looking chest, and that's all just scarring from fighting each other. They'll kind of rear up in the sand and slap forward and hit the chest of the rival male and bite each other, and it can get really rough. But those fights actually don't happen as much as you might think, because, and this is work from a researcher at UC Santa Cruz, Carolyn Casey, who was looking at the vocal patterns of elephant seals. So if you're at the beach and you watch them, you'll see one male is sneaking up to females that aren't his. The dominant male notices. He rears his head up and he calls, first of all. It's just like the warning.
Yeah.
And usually this stranger male that's coming up will hear that and be like, nope, turn around, leave. And it turns out that they recognize each other individual basis based on their calls. and they remember if they've had interactions with that seal before. So this rival male that's coming up hears that big one call, remembers, oh, 2 weeks ago I got beat up by him. Nope, not going to do it. Turns around and leaves. So they're able to avoid a lot of the actual physical altercation, which takes a ton of energy. And they're so heavy. You know, imagine trying to move that amount of mass over a beach. They can move a lot faster than you probably think. However, especially when they're fasting, you don't want to waste that energy. So there might be more fights at the beginning of the season while they kind of figure out, you know, who's dominant, and whose beach is, or which beach belongs to who. And then they can kind of keep control by that, kind of the social standing that they've established, which can last several years too. They can be remembered from previous years.
What's the ratio of males to females then?
In terms of numbers?
Yeah.
I think initially, in terms of pups being born, it's very similar, but males have a shorter life expectancy than females, probably because of that higher risk that they undergo while at sea. So I'm not sure about the current standing population, but definitely more females than males is what you would see if you go visit during the breeding season.
Well, I mean, I was asking because I was wondering, what do the non-dominant males end up doing? Just sort of hanging out?
Yeah, really good question. It turns out that if you are born a male elephant seal, your chances of actually reproducing, of being like this beachmaster dominant male, are extremely slim. About, or even less than 1% of all males born ever reproduce. It's bizarre. So yes, a lot of them just kind of hang out, or they'll just keep trying, and eventually they'll be big enough and strong enough to make it. But during the breeding season, you will see a lot of males that kind of just are a little further away from the action and hanging out. They know it's not their year. They know they're not big and strong enough, so they just kind of rest. And this is why you'll see males at nearby beaches sometimes, like at Waddell Creek. Sometimes some of those subdominant males will just go there because it's not worth the fight.
I wonder if their life expectancy is longer because they're not busy fighting all the time.
I think it's really smart. If you know you're not going to win, don't keep trying.
Right.
Wait a couple years until you're bigger. You may see them at the beaches away from Año Nuevo, just hanging out. And those aren't the full-grown males. They look massive, but those are the subdominant ones.
I see. You're listening to Sustainability Now. I'm Ronnie Lipschitz in the studio with Brooke Wright, and our guest today is Teresa Keats, a UCSC PhD student who studies elephant seals. And we were just talking about how elephant seals establish dominance. But I remember the question that I had before, Teresa, and that is that if the females only have one pup a year, how do their numbers increase?
Well, each female will live to about, I think the oldest female we know of is about 23 years.
Stupid of me, yes.
If they have a pup every year, your population would skyrocket.
Right, yeah. Well, that's just bad math on my part.
Well, actually, how about a related question, though, is how many years are they actually fertile and breeding like that?
Yeah,
if they live
excellent
23?
Question. So they can start having pups around 4 years old, and they'll have a pup every year unless, they don't find enough food or something. We do have females sometimes not give birth for a variety of reasons. And we don't really know if there is an age where they stop having pups, because we have seen individuals that we know are in their 20s still reproducing.
Wow.
They may not do it every year, but we have several that come back and are really up in the years, and they're just really experienced mothers. Often the older mothers are the better mothers. It's the young ones that sometimes lose track of their pups and have higher, pup mortality because of that. So they kind of start and just keep going, as far as we know.
are they protective of their pups at sea? I mean, do the pups go off on the migrations if they're females?
Not with their mothers. So if you are a elephant seal pup, you're born, you're already about 50 to 100 pounds. You are with your mother. You're the only child. You're in a big group of seals. It's noisy. Your job is just to stay with your mom and eat and sleep. And you are going to quadruple in size approximately, drinking this milk that is about 55% fat.
Wow.
Compared to cow's milk, which is about 3.5% fat. So by the time you're done with, or by the time your mom leaves, you're about 200 to 375 pounds. Big pup. Some of them will actually reach upwards of 400 pounds. These are mostly ones that are really clever and try to steal milk from other females that are not their moms. But what happens is your mom just leaves. She has been fasting for a long time. She's lost about 30 to 40% of her body weight because she's been on the beach, not eating, just feeding her pup.
For how long?
For about 3 weeks. Wow. It's not that long, and this pup almost, quadruples in size.
Wow.
And it's really incredible to watch just physiologically. These seals show up and they're big and they're fat and they give birth. And as the weeks go by, they're just shrinking, getting so skinny. Meanwhile, the pup is like a balloon. So they're depositing all this energy into the pup. And then they leave. They have to feed themselves. And the seals left at the beach at the end of the breeding season are all of these weaned pups. No one teaches them. No one teaches them where to go, how to dive, how to forage. It's really incredible. So they just kind of hang out with each other. They splash around in puddles and kind of in the intertidal, learning how to swim. They'll hang out for about 2 months, also fasting. So I think it's pretty rough. Your mom leaves and you just have to fend for yourself. And then they leave on their first trip to sea. And we're still learning a lot about what happens in that first year.
What time of year is that they're actually, they're born kind of, could you give a little of the cycle, cycle of life for the elephant seals in Año Nuevo?
So the pregnant adult females usually come back in late December and through January. Most pups are born January, February. And then the females are leaving again late February. So that has just happened. It's an excellent time to go visit. And the pups will hang around for a little while after. There are some still on the beach now that haven't eaten since late February.
Oh, wow.
Yeah, so they've also lost a lot of weight, but most of them will be leaving now, and so it is now mid-April. Starting in May, all those adult females that left right after the breeding season to go get food will be coming back. So they have 2 periods on land. One is the breeding season. That is when they give birth to a pup and they mate. And when they come back again in the spring, so May, June, is the molting season. So this is when they lose all of their fur.
And where are the males this whole time? I mean, obviously they're here for the breeding.
They are here for the breeding season. They have a little bit of an offset schedule in terms of the molt. So they will be arriving a little bit later, and through the summer, actually, we have males at Año Nuevo. So in the upcoming months, it's going to be mostly females that kind of look like they're peeling. They have what we call a catastrophic molt because it just happens so rapidly and they're losing their fur and the upper layer of skin. And it just looks like they're peeling, like you could grab it, like a sunburn peel. That's how it comes off.
And when the females leave, are the males still there with the pups, or do they leave too at that time?
So at the end of the breeding season, the males tend to stick around a little bit longer just to try and mate if they can with more females, or the subdominant males try to kind of sneak in there. So they tend to stay on land a little bit longer, but then they too will leave because they have been fasting and need to feed themselves.
So why do the females migrate so far into the Pacific to feed?
So we don't know a whole lot about
Okay.
this depth zone that they're using, the twilight zone. So where they're diving really deep. They're diving between 400 to 600 meters, which, let me think, is about 1,300 to 2,000 feet.
Yeah.
Right? And the maximum depth is well over a mile that we've recorded.
Wow.
And they're diving usually between 20 to 30 minutes, but the maximum dive time we've recorded was an hour and 40 minutes.
Wow.
Insane. These are athletes. They are built for the ocean. And this whole time they're looking for food at these depths. And this depth zone we know has a lot of food in it, but we actually don't know how much. Scientists are trying to figure that out through a variety of methods. And we also don't really know the distribution very well. So I'm assuming that they have a good reason for traveling so far, because it's not easy. And I think that it's probably just because their food isn't very concentrated. They have to just kind of keep swimming around to find a lot of it. But that's another one of those insights that the seals are giving into their environment. Where are they going and why?
But there's no way to know what the food stocks look like out there at that depth.
There are some ways. The most common methods for doing this are either acoustically, so like a fish finder, essentially. Research vessels will have like what are called echo sounders, or you can send a net down there and actually like do a physical net tow to figure out what animals you find down there. But all of these are very limited in space and time and have flaws too. If you're trying to catch animals, a lot of them will swim away from your net. There's this whole discussion that everything that's based on nets might be an underestimate because, a fish can see it coming and swim away. And that using acoustic data is also, it's really powerful. I don't know that much about it. But you can't cover the entire ocean doing that. And it's an environment that is changing quite quickly and is important to a lot of different predators and is very hard to characterize. And the seals are kind of helping us do that.
Are there other species that are hunting at that depth?
Yeah. So beaked whales, for example, which are very understudied because they're extremely elusive. Several species of sharks, sperm whales. And another reason why this depth zone is so significant as well is a lot of our atmospheric carbon is stored in the deep ocean. And the way that process starts is at the surface of the ocean through photosynthesis. So your phytoplankton are fixing carbon through photosynthesis. And most of this doesn't ever sink into the deep ocean. It gets recycled in the upper ocean. Phytoplankton get eaten by zooplankton, get eaten by other animals that respire and release carbon again. And a small fraction of this makes it to the really deep ocean where there isn't a lot of life and the carbon can just stay there for like 1,000 years. That's how long it takes for the entire ocean to circulate. And this is really important these days because the ocean is storing so much of our excess heat and excess carbon, and having some of it away from the atmosphere is in our best interest. So if we think about the animals in that twilight zone, they tend to do this vertical migration. So they move up and down in the ocean on a daily basis. Often called the largest migration on Earth, just because the number of animals that do this every single day adds up to a lot of distance. So at night, they tend to come close to the surface. This is when most visual predators can't really see them, and most of the good food is near the surface. And then during the day, they move back down into deeper waters to avoid predators that can now see them because it's light. And if you look at the elephant seal diving behavior, it mirrors this exactly. They are diving much more shallowly during the night and much deeper during the day. And the reason that this is important for the carbon cycle, actually, is because these organisms will eat things in the shallow ocean and physically bring them to the deep ocean much faster than, say, sinking particles would do. So it's actually this really effective biological carbon pump, moving carbon from the near surface down to much deeper, making it much more likely that that carbon gets stored for a longer period of time. So that's another just kind of really big picture ocean cycling that elephant seals are kind of teaching us about where that might happen.
And
I think it's really fascinating.
By bringing the carbon down, you mean because of, like, how do they end up leaving carbon down there?
So they're physically swimming down, and down at depth, they're respiring. So breathing, but not because they're fish, and defecating and just doing their thing down there. We're still figuring out kind of how important that is. But I think it's a really fascinating concept.
Yeah.
What other marine and environmental conditions are inimical to elephant seals?
So, like with some things that put them at risk? Yeah. So elephant seals are quite lucky for being so able to move long distances, which means that if their environment is changing, they can usually make up for it by going somewhere else. This is something, like kelp forest organisms can't really do. So far they have seemed quite robust to most of the common effects that tend to degrade marine life. This does not mean they're invincible. They and other marine predators often kind of serve as these sentinel species, or these, like a canary in the coal mine. They can let us know that things are different. Maybe they're coming back skinny, or they're traveling to colder waters or further away, or the waters that used to be cold no longer are. So I think the major threat to them would probably be if their food supply shifts, which kind of remains to be seen. But there are definitely other threats as well. For example, plastics in the ocean. Microplastics, as your plastic breaks down but never fully degrades, is making its way into pretty much all parts of the food web. This hasn't really been studied in elephant seals very much, but is definitely a potential. And other pollutants as well. We have some information on mercury, for example, in seals. So mercury is natural. However, there's a lot higher concentrations due to fossil fuel burning, due to mining activities that ends up in the ocean. And that works its way up food webs, so that predators often have quite a heavy load of mercury. This is why they recommend, for example, that when you're pregnant, don't eat seafood of like higher trophic levels, like predatory fish, like swordfish, I think they say. Don't eat that because of this contamination. And the seals definitely have it as well. And we're still kind of figuring out how much that affects them, but that is certainly a stressor. And a lot of it goes straight into their milk and straight into their pups.
This is Sustainability Now. I'm Ronnie Lipschitz in the studio with Brooke Wright, and our guest today is Teresa Keats, a UCSC graduate student who studies elephant seals. And Teresa, we're reaching the end of the program, so maybe you can tell us a little bit about...
Oh, wait, I have a question.
Oh, sorry, Brooke. Go ahead. I wasn't going to finish, but go ahead. Yeah.
Okay. I just wanted to ask, we sort of touched on talking about how it went, at one point they were believed to be extinct. And I was just wondering if you could share just what's happened over the last 100 years with the population of elephant seals.
So at the turn of the century, they were thought to be essentially extinct.
And that's the last century. right?
Oh, yeah.
Yeah.
Yes.
The other one.
The early 1900s. We thought the population was maybe as low as, we now think it was maybe as low as 20.
Wow.
This is because they were hunted primarily for their blubber as a fuel source. Similar to whales, like that fat is very useful. And the reason they survived is probably because the population has this offset schedule for different age classes and for males versus females. So we mentioned that, the males come back to molt a little bit later than the females. So when the scientists or the explorers back in the really early 1900s thought they were extinct, there were probably still some seals at sea. And once the hunting was banned, the hunting for blubber, they were able to make a really rapid and remarkable comeback. So it was really just changing the laws and no longer exploiting the population that allowed them to explode. And now the worldwide population is somewhere between 210 and 230,000 seals. At Año Nuevo, it's about 10,000, with about 5,000 seals at the beach at any one time at peak.
Wow.
Just a lot of seals right in our backyard.
And is it just kind of in a stasis? Like, has it been the same levels for a few decades now, or is it still growing, or what do you see in the last, let's say, 30 years?
I think it's kind of petered out a little bit, but we still see them extending to new areas, which is kind of the sign of population growth. For example, there's what is looking to be a new colony up at the Lost Coast, away in Northern California.
Wow.
There used to not really be elephant seals there, but every year there's more. They've started breeding, so that might be the next big place. So they are still growing. Mostly, I think we see that in terms of their spreading out to new areas.
And is there a downside to too many? Is it ever a bad thing that there's too many elephant seals?
I don't think so. I mean, I don't think we really know what the pre-exploitation population size was.
Right.
But no, I think there's plenty to go around.
I wanted to ask about if there were only 20 left. That sounds like a real genetic bottleneck. Do you see that in the populations? And does that matter?
So both because there were so few left, and like we mentioned before, only about 1% of the males ever procreate. Mm-hmm. And that means that male's genes is in a lot of offspring. Yeah, the genetic diversity is extremely low, and they seem to be doing fine. Given a lot of time, evolutionarily, they will get some diversity back.
Right.
It does mean they're a little bit vulnerable. If some disease were to sweep through the population, for example,
it also makes you wonder if they would have. We know them to live about 20 years, but 150 years ago, did they live 40 years because they had more?
Excellent point. Yeah, we don't know. So if one is vulnerable to some disease, they're all so closely related, they're probably all vulnerable. So far, so good. Mm-hmm. But yes, it definitely puts a population at a disadvantage to be so genetically similar to one another.
So as we're getting to the end of the show, maybe you can tell us when are the best times to see elephant seals at Año Nuevo, and how should people behave around them?
So if you would like to see the drama of adult males vocalizing at each other and sometimes fighting, and see pretty cute elephant seal pups, I think February is your best bet, kind of the peak of the breeding season. And there are guided tours daily at Año Nuevo. And then really anytime that you go, you will probably see some seals. The other peak is this molting season. So in May and June, there are a lot of seals around. Mm-hmm. And we mentioned before that you might encounter a seal at, say, Waddell Creek or something. And I just want to emphasize the point that we are lucky to share our home with these animals. It is their home too. And we need to give them their space. These big males may look like they are napping, nothing could bother them. But they really need this time to rest and recuperate, both for their safety, for your safety. Just keep your distance. Don't let your dogs get up to these or get close to these seals. Don't try to take selfies. It is also against federal law to get within 50 yards of them. Respect them, appreciate them from a distance. And I'm sure you'd rather see wildlife doing its wildlife thing rather than scared wildlife because you're stressing it out. At Año Nuevo, the docents are very, very careful in terms of making sure you're not too close. You can take your photos, you can enjoy the seals, and don't scream or run around. But I think importantly, it's just if you see wildlife, let wildlife be wildlife.
It must be very hard for children to not run around screaming when they see elephant
I mean,
seals.
And some adults.
The children elephant seal are screaming a lot. So yeah. I guess that's fine. Don't approach wildlife for their sake and for your sake.
As the last point, you said you wanted to tell our audience what we can do to help protect our oceans. So I'm going to give you liberty to talk about that.
Thank you. Going along with just, respecting these animals, seals, and any other wildlife that we share our home with, how to make this home still be a home for them in the future. And I know this is probably preaching to the choir to your audience, but just things we can do to be better stewards here in the Monterey Bay Area and also on this planet. Reducing your carbon footprint is something that will benefit pretty much everything. And a thing that I think we can do locally that will make a difference is like reduction of single-use plastics, for example. Plastics never go away. On the time scales of any importance to us. And a lot of it ends up in the ocean. And picking them up off the beach is great, but we really also just need to use less of it. And lastly, I'd say when it comes to, trying to maintain a healthy planet for the future is to vote if you're able. If there are any issues that you care about, whatever the issues are, make sure that that is reflected in your elected representatives. That is what they're there for. And we're very lucky to live where we live with all this amazing natural richness around us. And I just hope that we can maintain that for future generations.
Well, thank you, Teresa, for being our guest on Sustainability Now.
Thank you so much for having me.
Where can our listeners learn more about your work?
So the Costa Lab at UC Santa Cruz has a website that you can find if you Google it. Otherwise, I also sometimes tweet about my research, which you will also find if you Google my name. And I think, there's a lot of really cool research coming out of both our lab and UC Santa Cruz in general that you can learn about through the UCSC news resources as well, which are really great.
Thank you. This is Sustainability Now, and you've been listening to a rebroadcast of a 2020 interview about elephant seals with Dr. Teresa Keats. If you'd like to listen to previous shows, you can find them at ksquid.org/sustainabilitynow and Spotify, Google Podcasts, and Pocket Casts, among other podcast sites. So thanks for listening, and thanks to all the staff and volunteers who make K-Squid your community radio station and keep it going. And so, until next every other Sunday, Sustainability Now.